Okay. So, so firstly, hello everyone. Welcome back to our session at Easy Chemistry. So this is a knowledge sharing or a knowledge interactive session. The difference between the normal knowledge interactive session and this session is we will not have a real-time interaction, but yes, if you have any questions, any doubts, you can post in the comment section below. And if you really like this video, kindly subscribe to this channel as well. So, dear students, today we will be sharing some very brief information about organic chemistry. If you would have gone through my channel and seen previous videos, you would see that I have given sufficient videos on organic chemistry. But this topic is of such a nature that if we give one video, I want to give two more or three more. So this is one of the most interesting topics or subjects in chemistry. So children, you must have understood or known or heard that chemistry can broadly be divided into physical, inorganic and organic chemistry. These are the three main branches of chemistry. If we go into the details of the branches, there would be lots more to cover. So organic chemistry, as the name suggests, this branch of chemistry would have dealt with any chemicals which are produced or released by any organism which has life. However, this myth was busted not long ago after this theory was floated in the market. One of our eminent chemists made urea in the chemical lab, and then we came to a conclusion that organic compounds can be synthesized bioorganically or even in a chemistry lab. But the branch of chemistry was always called as organic chemistry. Now, my dear children, organic chemistry has a very important place even in our daily lives after education as well. You would think that this is very funny and ironical. However, this organic chemistry is in our life from the morning when we get up to the time we go to sleep. Medicine, soap, shampoos, chemicals, perfumes, deodorants, everything which has chemical is chemistry, and everything which is chemistry used in daily life is organic chemistry. So, my dear children, you must have also heard from your teachers and or read in textbooks and reference books that organic chemistry is in existence because of the bond between carbon and hydrogen. So, as you would have heard earlier that Adam and Eve were the reason why civilization began in this world, similarly carbon and hydrogen are the reason why we have organic chemistry. Carbon is very special because it is an element which has 2 electrons in the inner shell and 4 electrons in the extra orbit, which is the p orbit. So carbon, the nucleus has in carbon, the size of the nucleus is so small and the charge contained is of such a magnitude that the carbon, if it loses 1 electron, the nucleus will not be able to sustain itself and carbon would degrade or be very unstable. That is why carbon is the only element which shares electrons to form compounds with hydrogen. So organic chemistry is the backbone of organic chemistry is carbon and hydrogen. Now, coming back to the types of organic compounds. As you would be able to see on the board behind me, organic compounds are divided as acyclic and cyclic compounds. Acyclic compounds are those compounds which are open chain compounds. Open chain compounds can further be divided into saturated and unsaturated compounds. Saturated compounds are alkanes, unsaturated compounds are alkenes and alkynes. So as the name suggests, saturated compounds cannot take in anything but can share or lose electrons to form a new product during the chemical reaction. Now, my dear students, chemical reactions in case of organic compounds is very unpredictable. Sometimes it could be very slow, sometimes it could be very fast. So looking at this, the organic chemical reactions have to be very closely followed. As a result of which the saturated compounds can only lose or share electrons. The compounds which are unsaturated can even gain electrons. This is similar to what we face on our daily lives. For example, when we are hungry, we want to eat more. That is unsaturation. But when we are full to the neck region, we refuse to eat more. That's because we are already saturated with food. So it is point that needs to be noted as alkene and alkynes are unsaturated compounds and saturated compounds are alkanes. These are the division of acyclic compounds. Now, going by the point of cyclic compounds, cyclic are closed chain compounds because the word cyclic means in a given cycle. So they are closed chain compounds. Now, the closed chain compounds can further be divided into homocyclic and heterocyclic. So these are the basic descriptions of organic chemistry and its compound. We will be back in the morning tomorrow with further discussion on these types of compounds. Hello my dear students, today again we are back for the continued knowledge sharing session regarding organic chemistry. So if you remember from our discussion yesterday, we said that there are mainly two types of hydrocarbons, one being saturated and the other being unsaturated. So saturated, what I explained yesterday was, they can only share or lose electrons, they cannot gain further electrons. So to begin with, the starting component, if you remember the tabular differences, you would have seen that the acyclic organic compounds were divided into saturated and unsaturated. So out of saturated compounds, we had alkane. So today we will be discussing about alkane. Now, my dear students, you would have heard about it before as well, that there is a unified council which decides upon the names and the chemical structures of the general formulas. So alkane as a chemical compound is a part of a homologous series. Now, when we say homologous, what I mean is a series of chemical compounds or elements in which the given particular chemical or physical properties are repeated after a given number of compounds. Which means if the compound 1 has a non-polar structure, compound 7 or compound 8 may have a non-polar structure too. So a homologous series is either a gradual, identified, united kind of an increase or change in the properties, or repetition of properties in after a given number of chemical compounds. So now we understand what a homologous series are, don't we? So then there was a statement that these kind of compounds are saturated compounds and they should be having a general formula or a generic formula. So what is the difference between a generic formula of a homologous and a generic formula of a heterologous series? As we know by now that homologous series are the ones in which the properties are repeated. So we can very easily say that they'll have a common generic formula for the entire series. Which means if I say the formula is CnH2n plus 2. What I mean by that is, if there is one atom of carbon which is involved, there are 4 atoms of hydrogen that needs to be used so that this carbon forms a healthy and a stable compound. So if you guys recall, the chemical formula of methane is CH4. Now the CH4 can be broken down into Cn, H2n plus 2. Replace the value of n with 1, you see C1H4. Similarly, if I go to the next compound of this homologous series, I will be standing at the face of ethane. Ethane is C2H6, which means N should be replaced by the value 2 because first compound is N where N is equals to 1, second compound N should be equals to 2. So you will see C2H6, that's methane for you. So these kind of a gradual change in the compound's physical as well as chemical properties are a characteristic of the homologous series. Now, in your country or in my country or across the world, we will call methane methane only. It will not become ethane or butane or methyl or ethyl. That's because in the year 1972 or slightly before that, around 1969, there was a group of scientists who formed a group called International Union of Pure and Applied Chemistry. This organization that was formed was not like a union which would fight in factories. However, this was a body which performed the work of releasing or setting up standard nomenclature across the globe. Otherwise, in Asia, if someone would call methane, in Africa there was a possibility that they would be called ethane. So to avoid these kind of confusion, this union set up a unified system of nomenclature so that there is no difference and we don't face any kind of a difficulty. Now, physical properties of organic compounds, right from the baby alkane to alkyne or alkene, is one particular thing is common. They have a non-polar structure. Why do they have a non-polar structure? Because polarity is similar to ionic levels. Because any substance which occupies or has a polarity is because of the ionic levels or ionic compounds. So that kind of situation is not prevalent for organic compounds. The reason being carbon cannot lose electron, it can only share or carbon cannot gain electron, it can only share or lose electron. So in this situation, what particularly happens is the entire series wherein the carbon and hydrogen are involved, be it homologous series for saturated or unsaturated, the bonding is covalent bonding, so they are non-polar compound. Because non-polar compound means one of the participants of the compound must be negatively charged or positively charged. Also, because they are non-polar structure, they are reasonably less soluble in water. And as far as their chemical properties, they can be found in halogenation, many industrial processes, right from dry cleaning and many other uses. So organic compounds as low as or as saturated as alkane is also very useful. So going forward we'll be doing such sessions maybe later half in the day today or tomorrow on alkene and alkyne. Thank you so much. Wait for our next update.